Today, we're going to put the finishing touches on our Water Caustics decal projection shader. Let's go. All right, so for the last couple of weeks, we've been creating this water shader. And last week, we created a decal projection shader that created these caustic patterns. So if I kind of come down here underwater, you can see that we've got caustics projected all over the rocks and the ground under the water. But when we left off last week, we discovered that there were two problems that we wanted to fix. The first problem was that the edge of our caustics patterns is really hard. We have a hard edge there and it just kind of chops off instead of fading out nicely. And the second problem is that our caustic patterns, especially on the rocks here, you can see that there's this really noisy issue going on with the tiling of the caustic patterns. And so in today's video, we're going to fix those two problems. We're going to start out in Unity today, and then we'll switch over to Unreal, and I'll show you how to do the same things there. So first of all, let's talk about these noisy normal issues that we're having. So the reason that we have all of this noise on the rock is because of the normals. Let's pull up our analysis rendering debugger here and switch over to our normal view. And here our colors represent the directions that the surfaces are facing. You can see, especially on these rocks here, that our normal map is really noisy, and wherever our normals switch between front and left or top and right, etc., we get a border in our caustics. So here you can see this hard edge, and here and here. So wherever our normals are switching from pointing in one cardinal direction to another, we get this really noisy edge here because of the surface normals. And so what we really need to be able to do is soften our surface normals so that we don't have those hard edges. It would be especially nice, ideal in fact, if we had access to the vertex normals or geometry normals of the surface instead of the normal map normals like we have here. But we don't actually have that. So what I'm going to show you is the next best thing. Let's go ahead and switch over to our shader. So this is the shader that we created last week. And you can see over here, these are our UV coordinates that we're using. And then here are the caustics patterns that we're projecting. And then this is the normal map that we're using to distort the caustics projections. So what we have here is our HD sample buffer node, and we're using this to sample our world space normal, and then using the direction that the normal is facing to blend between our front, back, and sides UV coordinates here. So we need to find something else other than HD scene buffer. And what we're going to do is use derivatives to calculate the face normals of the meshes in our scene. All right, so how do we do that? Well, we start out with our position, and we're going to set our position to absolute world. And then we're going to take the derivatives of the position. So we'll add our DDY and our DDX nodes. And so what this is doing, it's looking at the positions on the screen and comparing the positions of the current pixel with the pixels just above it for DDY and just to the right of it for DDX. And it gets the difference between the current pixel and the pixel above and the pixel to the left. Now, if I take the two differences and do a cross product between them, what that'll give me is a world space normal. This is a really nice trick. But the world space normal is so small, you can't really see it here in the preview. And so what we need to do to fix that is just to add a normalize node. And now you can see from the derivatives of the position and then the cross product of those derivatives, we've computed a world space normal. Now, you may notice here that in the preview sphere here, it looks really faceted. And that's because we're computing the normal per face, not per vertex. And so there's no blending between these faces. But I think you'll see that that doesn't matter too much. It does cause a little bit of artifacting, and I'll show it to you. But I think the results are better than what we had before. So let's just take a look here really quick. This is what we look like now on our rock. We get lots of noise here where we're transitioning between normals. And what we're going to do instead is use our face normals to make that transition instead of using our pixel normals. So let's save this and switch back to our scene. And now you can see that we're using the normals of each face to transition instead of the normals of each pixel. And so we kind of isolated those transition artifacts to the edges of faces. So if we fly around here, you can see on a rock like this, we get transition artifacts on the edges of polygons instead of on the edges of pixels. So let's switch here and take a look. Here you can see I've got tons of noise on this rock. And then here, you can see that that noise has been eliminated because we're using our vertex normals instead of our pixel normals. All right, so I'm just going to fly around here a little bit, and you can see that we no longer have any of that crazy looking pixelated noise on our projection for the caustics. All right, it's looking pretty good. The next thing that we want to do is get rid of this hard edge. And this is a problem with pretty much all decal projections. We want the decals to kind of have a smooth transition and fade out at the top, at the bottom, at the left and the right. And right now, wherever the decal ends, we're going to have a hard edge. So let's go ahead and create an addition to this shader that masks off these edges. So, one thing before we do that, it's really handy to have this set of nodes here as a subgraph. And I've gone ahead and done that. So I've named my subgraph face normal. And here is my face normal subgraph. If I set it to world space, you can see that this subgraph here is basically doing the same thing as this set of nodes. So now I can plug this in and just get rid of these. This subgraph contains this set of nodes here. And so now I'm using my face normal subgraph. You may run into other situations in the future where you want to use face normals. So it's handy to have this face normal subgraph. All right, let's switch over here to the end of our shader. Right here is where we're going to put the mask in that masks off the edges. So we get a smooth fade out transition. All right, so once again, we're going to put down a position node. And we're going to set our position to object space. Now what this gives us is the boundaries between our decals. So from 0 to 1, our decal is going to, from one edge to the other, we're going to get 0 to 1 using our object space position. So the first thing that we're going to do is add 0.5. And this is going to put the center in the center. Instead of going to 0 to 1, it's going to start out with 0 right in the middle of the decal. That's what adding 0.5 is doing. And then we're going to multiply this by itself, basically. So I'm going to take our position here, and I'm going to do a 1 minus to invert the position, and then multiply it by the 1 minus version. And that's going to give us some masks here that we can use. And let me just split this out so you can see what the X, the Y, and the Z are doing individually. So I'm going to add a preview node so that we can see what the X, the Y, and the Z are doing. Let me actually switch the preview type here to 2D so it's a little bit easier to see. All right, because I've multiplied by 1 minus, what you can see here is I get a gradient that goes from 0 to 0.5 here in the middle to 0 again. So the X, or the red channel, goes in the horizontal direction. The green channel goes in the vertical direction. And then the Z, or the blue channel, goes in the in and out direction that we can't really see in a 2D preview. And so now what we need to do in order to make an edge mask for our decal is just take these 3 components and multiply them together. So I'm just going to multiply the X by the Y. And you can see our mask is starting to come together now really nicely. And then I'm going to multiply it by the Z as well. Now, if we multiply a bunch of numbers that are all smaller than 1, we're going to darken them down significantly. So you can see our result here is very, very dark. It's very subtle. And so now what we need to do, now that we've created our mask, we need to multiply it by some higher numbers to boost its strength. The first thing that we're going to do actually is multiply it by itself, just to give it a little bit more round shape. And then we're going to multiply it by a really high number. I'm going to multiply this by a value of like 50,000. And now you can see I'm getting this kind of this fall off pattern. And if I switch my preview to 2D, you can see that I'm getting this mask that I was looking for. I've got black over here on the edges, and then it slowly fades into white here in the middle, which is exactly what I'm looking for. And it does this in all 3 dimensions. So if I multiply the contents of my decal projection shader by this, it's going to mask it off at the edges. So here at the end, I'm just going to add a saturate to make sure that we don't go below 1 or above 0. And now I can use this value as my mask to blend out the edges. So I'm just going to come down here and add a multiply at the end and blend out my edges. And you can see here, whereas before I had the pattern going all the way to the edge, now you can see that it's nice and soft and kind of blends out at the edges, which is exactly what we're going for. All right, so I'm going to wire this in, and then we're multiplying by 10,000 here at the end, just to brighten it up, because in HDRP, the emissive input takes the emissive in kind of a real world, like lumens or something like that, and we have to have these kind of like really high values in order for things to show up correctly. All right, so I've got my mask here, and once again, just like I did with the face normal node here with that subgraph, I also created a subgraph for my edge mask here. I think I called it decal edge mask. Yeah, so there's my decal edge mask subgraph. I just took all of these nodes and encapsulated them into a subgraph. And then I exposed this parameter here, and I just called it sharpness. So the higher that value is, the sharper my edges are going to be. So here I've got it set to 50,000, and if I set it to 100,000 instead, you can see that those edges are just getting sharper and sharper. I think I'm going to stick with a value of 50,000, and we'll just wire this in and hit save. Now let's switch back to our scene. And yeah, so if we come over here to the edge of our decal, you can see that we're no longer getting that really harsh, hard cutoff on our decal, but it's actually fading out nicely for us. All right, so let's take a look at our final result. You can see that we no longer have those kind of noisy, pixelated edges, and we also have a nice fade out on the edge where our caustic decal cuts off. Instead of cutting off as a hard edge, it's blending out nicely. So today we added our face normals here that we're computing using derivatives. And we also added our decal edge mask. And by the way, you can use this decal edge mask for any decal. It doesn't have to be this specific water caustics decal, but any decal that you use that's projecting in all three axes that has a hard edge, you can use the decal edge mask to fade it out on all three edges. Pretty nice. All right, I think that's gonna wrap it up for our series on water shaders. There's a lot more that we could do with water shaders, but I have another exciting topic that I'm gonna introduce in a couple of weeks. I'm gonna take next week off. I'm not gonna create a video next week, but then the following week, we're gonna start a brand new topic, and I know that you guys are really gonna like this one. All right, let's switch over to Unreal, and I'll show you how to do these same kind of polish items on our decal projection shader. All right, here we are in Unreal Engine, and just like we did in Unity, we've been creating a nice water shader here. And last week we created the Caustics decal projection shader. And so if we come under here and under water here, you can see we've got these really nice Caustics patterns projected on everything. All right, now just like we looked at in Unity, we have those two same issues. First of all, you can see that our Caustics patterns have these really noisy patches. And then second of all, there's kind of a hard cutoff on the Caustics. Now there is one thing that I learned about Unreal that's different from Unity. If we come up here to the edge and you can look here, there's no hard cutoff at the top of our decal. And that's a difference between Unreal and Unity. So let me just show you this really quickly. Here's a default decal that I added to our scene. And you can see that the edges here are hard, but then there's this nice fade off at the top. So Unreal automatically applies this fade off to the top of the decal, but it doesn't apply a fade off to the edges. Like it has a fade off on the Z axis, but not on the X and the Y axis. So these are the two problems that we're going to be fixing today. We're going to fix sort of this blotchiness that happens, and then we're also going to add fade off to the edges of the decal. All right, so as we talked about before, this blotchiness is happening because we're doing a triplanar projection of the coordinates and then projecting our caustic pattern using these coordinates. We're swapping between the coordinates using the pixel normal, and we actually need to swap using a normal that's a little bit smoother. So let's take a look at how to do that. Here's our shader. And we have our two scrolling Caustics textures here. We have our normal map here that is distorting the coordinates before we sample our Caustics textures. And then we have this portion here that is blending between our three different projection coordinates using our scene texture world normal. And this is the problem right here. Our world normal is just a little bit too noisy, and it causes too many transitions, and so we end up with that patchiness. And so instead of using this world normal, what we're going to do is use our world position node, and we're going to find the derivatives of the world position, and then do a cross product between those derivatives to compute the face normals instead. And so I'm going to add a DDY here, and I'm going to add a DDX. And so this is going to give us our derivatives. What this does is it takes a look at the pixel that I'm currently rendering, and for DDY, it takes a look at the pixel that's just above it, and for DDX, it takes a look at the pixel that's just to the right of it, and it compares the current pixel with the one just above it or just to the right of it and gives me the difference between those two. And that's the same thing as shooting a vector to the pixel next door. And so what I can do is take the cross product between those two vectors, and that's going to give me the world normal. And you can't see it very well, and so what I'm going to do is, because it's so small, because it's just between the current pixel and the one next to it. And so if we normalize that, that's going to create a vector that is unit length now that we can use. And so this node here is giving us the scene texture world normal per pixel normal, and this one is giving us a per face normal. So let's plug this in instead and save our result and take a look at what we can see in the scene now. All right, so now you can see that those splotchy patches are gone, and we're projecting and transitioning between our projections per face instead of per pixel. So now you can see I have a seam kind of right here, but it's not as harsh and kind of ugly looking as what we were seeing before. If we switch back to our world normal here, our pixel normal, you can see that I've got this kind of ugly patchiness. But when we use our computed face normals, now you can see our results look a lot more natural and smooth. All right, so that's the first problem solved with our caustics. And the second problem is that we wanted to kind of fade them out at the edges. So in order to fade out at the edges, what I'm going to do is bring in my texture coordinates. And this is going to give me the dimensions of my decal in X and Y. Usually texture coordinates take the UV coordinates from the mesh, but since a decal doesn't have a mesh, it's actually going to give me the dimensions of my decal. So it'll go from 0 to 1 in X and 0 to 1 in Y. So if I want to make things fade out, I can just add a 1 minus node here to invert my results. Then I can take my results and multiply them by the inverted results. And now you can see I'm getting a little bit of a mask. So I have a mask here on the y-axis and a mask here on the x-axis. And now I can split my results out. I'm just going to use a component mask for this. And I'm going to mask out the red channel. And then I'm also going to mask out the green channel. And then I'm going to multiply these two channels together. And let's take a preview of this. And now you can see it's really subtle, but you can see that there's this kind of nice soft border around my UV coordinates. And if I want to kind of round it out a little bit more, I'm going to multiply it by itself. Now, what I end up with all of these multiplies is something that's really dark. And so what I need to do after doing all of these multiplies is one more multiply, and I need to kind of boost this up. And so in my case, I'm going to multiply this by 1,000, and now you can see it's significantly brighter. And if I want to get this mask to go to the edges a little bit harder, I can just increase my value here. And you can see like the higher I make this value, the further and closer to the edges I'm going to get. So I can have softer edges with a lower number here, or harder edges with a higher number. And now all I need to do is saturate my result. And I've got a mask that I can use to soften the edges of my caustic decal. So I'm going to come down here right before the end and just multiply my decal by my mask. So I'll just take my mask here and wire it in, and then wire the result into the end there. And you can see I'm multiplying by 2 here at the end, and that's just to kind of brighten up the brightness of the caustics. All right, so this is something that you could take and encapsulate in a material function, because you may want to fade out other decals later on. So if you created a decal fade material function, you could do the same with those nodes there. You can also take these nodes here and create a face normal material function that computes your world space face normals using derivatives, because that could be a useful material function to have as well. All right, so there's our shader. We'll go ahead and save it and take a look at the final result. So now we have a decal that has nice soft edges, and it will fade out in the corners. Like if we come over here, you can see how it's fading out over here in the corner. And also we've gotten rid of that kind of ugly splotchiness that we were having, where it was transitioning on a per pixel basis using pixel normals instead of vertex normals. All right, so let's take a look at our result. We've got our nice caustics patterns projecting there. We've got our water shader that's doing our really cool looking animated vertex waves, surface ripples, depth, and foam. And overall, I'd say this series of videos has been a great success. All right, as I said before, I'm going to take next week off, so no new shader video next week. But the week after that, I'm going to be introducing a brand new series on a topic I really think you're going to enjoy. This is something that I've had fun putting together for you, so be sure to come back for that. Thanks a lot for watching, everybody, and we'll see you next time.